The Pythagorean theorem deals with right triangles. So let me draw a right triangle here. This should feel like a refresher, but I will also present the material in a way that a little different than what you might be used to, so make sure that you're paying careful attention. Okay, so the Pythagorean theorem only applies to right triangles. So here is a triangle with a right angle, so it's a right triangle. I will label the sides, and typically we label the hypotenuse, which is the side opposite the right angle, as side C. You must always identify the hypotenuse first. That's the important side to notice first. Because the Pythagorean theorem, you might be used to it as a squared plus b squared equals c squared, but I'm going to present it as c squared equals a squared plus b squared. So we must identify the hypotenuse first because it is going to be on its own side of the equal sign, and we're going to write it down first. So the hypotenuse squared is equal to one of the legs squared plus the other leg squared. So keep in mind that A, B, and C are lengths, and they're numbers, okay? So the most important thing you can do to begin with the Pythagorean theorem is identifying your hypotenuse. Remember, it is opposite the right angle. Find your hypotenuse, whatever that length is, square it, and that's going to be equal to the sum of a squared and b squared. So a little bit more vocabulary here, just so that we're all clear. You must identify the hypotenuse first, and then a and b, the non-hypotenuse sides of a right triangle, are known as legs. So that's a leg and that's a leg. The Pythagorean theorem, in words, says that the hypotenuse squared is equal to the sum of the squares of the legs. So again, I know I keep stressing this point, and I want to continue to stress it. Always identify your hypotenuse first. Why? Because it's on its own side of the equal sign. It's on its own side in the Pythagorean theorem. So you have to identify that first, otherwise you can mix things up. So here we are asked to find the missing side. That's really what we're going to be doing throughout this video, and we're going to apply the Pythagorean theorem to find a missing side. So the first thing we have to do is identify our hypotenuse. Notice how the hypotenuse is opposite the right angle. I say you should even, write yourself a little note. That's your hypotenuse. Now recall, since this is a right triangle, we should probably just write down the Pythagorean theorem in general first, and then, since we've kind of keyed in or dialed into the hypotenuse, we know that the hypotenuse is 21. And that is going to be on its own side of the equal sign. And then A and B, it doesn't really matter the order. We know that these are the legs. You could call one of them A and one of them B. It's just very important that you notice carefully what the hypotenuse is. So A, let's say, is x, and B, let's say, is 9. So we've written out our Pythagorean theorem here with the hypotenuse listed first. Now, and 21 by 21 is 21 squared, so that's 441 when we multiply that out. Recall that we are multiplying. We have x squared and 81. Now just be careful. With PEMDAS, we have to make sure we square each side before we sum them, and we can't put these two numbers together because they're not like terms. So now we're going to just isolate x and solve like we're used to. So now I have 361 is equal to x squared. Oh, so is this side length, 361, big? Well, that wouldn't make sense. That wouldn't make a triangle. So recall, to undo or the inverse of squaring is going to be square rooting. So we're going to square root both sides to help us kind of solve this out a little better. Okay, so now x is going to be the square root of 361. It is true that I probably should have put a plus or minus there, but we know that this length is not going to be negative. So we found the length of the missing side to be the square root of 361. Now you should ask yourself, can you simplify that further? And actually, 361 is a perfect square. 19 times 19 perfectly makes 361. So our final answer is that x is 19. Now keep in mind, sometimes you'll have answers with ugly square roots that sometimes perhaps can't be broken down. Sometimes they can be broken down or simplified in some way. Sometimes you might end up with a perfect whole number. Anything is possible. Okay, so very good. We found the missing side. So here in this example, again, we're trying to find the missing side. We don't even really need those directions. It's kind of implied that we're supposed to find x. So again, to begin every problem, we must identify the hypotenuse. The hypotenuse is across from the right angle. So here's our hypotenuse. We really want you to write that so that you're mindfully engaging in the problem and you'll be able to set everything up correctly. Recall that the Pythagorean theorem states that the hypotenuse squared is equal to each of the legs squared summed together. Okay, so we have our hypotenuse squared. We dialed into that first. We located the hypotenuse. And then we can just pick either of the legs. One of the legs is 5. That's going to be squared. And the other leg is 5 root 2. That's going to be squared. Okay, now remember, squared means multiplied by itself. So what's different from this problem than the previous is in this problem, we are trying to, the missing side that we're trying to determine is in fact the hypotenuse. In the last example, it wasn't the hypotenuse, but that's okay. All right, so we have x squared. That's our hypotenuse squared. 5 squared is just 5 times 5. That's 25. Now be very careful when squaring 5 root 2 squared. I might even rewrite that over here. Remember, squared means multiplied by itself. So we have 5 times root 2 multiplied by 5 times root 2, and there's even multiplication there. All those little dots are like multiplication. So if you want, we can kind of reorganize this a little bit. Since all of these things are multiplied together, we could think of it as 5 times root 2 times root 2. You can just kind of mix up the order in multiplication. That's fine. You know, 7 times 2 is 2 times 7. That just works out. So 5 times 5 is 25. And then be very careful here. The square root of 2 times the square root of 2, well, you can multiply them together underneath this one root. 2 times 2 is 4. Oh, what's the square root of 4? That's 2. Now the 25 and the 2, they're standing right next to each other, so they're multiplied. So that last side is 50. Okay. So, last side squared is 50, really. So now we're solving for the hypotenuse, and we know that the hypotenuse squared equals 75. Now we square root both sides. So you might be content with saying x is the square root of 75, but you should always ask yourself, can we break this down further? Now remember, we had some multiples of 25 here. We had 25 times 1, and then this turned out to be a 25 times a 2. So we really have 3 25s making up our 75. So we could apply the square root to each little piece. And so x is going to be 5 square roots of 3. And you can also just kind of check yourself. Is that number larger than either of the legs? It's certainly bigger than 5, and yes, the square root of 3 is bigger than the square root of 2, so when you multiply it by 5, the hypotenuse is the biggest side, and we have done a good job applying the Pythagorean theorem yet again. So here's another example, and now we're trying to find a couple of missing sides. We're going to end up solving for x and then plugging in and figuring out what those missing sides are equal to. Okay, so this is a right triangle, so we may apply the Pythagorean theorem, which is the hypotenuse squared equal to one of the legs squared plus the other leg squared. So we must identify our hypotenuse first. That's opposite the right angle. Here's our hypotenuse. That number stands alone and is squared. That's equal to each of the other legs squared and then summed together. Okay, so now we're just going to kind of clean this up and work it out. It's going to feel like the same experience that we had in the last couple problems. It just might be a little bit different in the end. Okay, so 9 squared is 81. Okay. 3x squared, well, that's 3x times 3x because remember, squaring means multiplied by itself. Use this technique to just write it out and give yourself more access to the problem. Okay, we have 4x times 4x. That's 4x squared. Just write that all out. You'll be more successful if you do that. Okay, so now we have 81 equals 3 times 3 is 9. X times x is x squared. Okay. 4 times 4 is 16. X times x is x squared. We can combine like terms. And now we want to get x alone so that we can square root. That's going to be a common occurrence in these sorts of problems. So now we know x squared equals 81 25ths. Notice 81 and 25 are numbers that you know the square root of, and aha, the opposite of squaring is square rooting. So I'm going to square root every single piece. X is equal to plus or minus, what's the square root of 81? That's 9. What's the square root of 25? That's 5. So x is 9/5. Now be careful, we're not done, because this side is actually 3x multiply 3 times 9, that's 27/5. And 4x, that'll be 4 times 9/5, that'll be 36/5. So this squared plus this squared perfectly makes whole number 9. Okay, now we've done a good job here finding our missing sides. There's going to be some practice next, so please make sure that you stay with the video and you don't just skip out on it. Here are 2 practice problems for you. Make sure you copy them down and you solve for x. They should feel just like the examples that we did. It's going to be a very similar experience. Make sure that you simplify your square roots in the end and you take your time. Don't forget to begin by identifying your hypotenuse, and just make sure both of these problems are done for next class so that you can get full credit. Good luck and have a great day. Good game.